Good morning, students. So yesterday in last sessions we have discussed with regarding to different sorting techniques, that is selection sort, heap sort, and then bubble sort technique. So now with the exchange sort, bubble sort comes under exchange sort technique. In that exchange sort technique, now we are discussing about quick sort technique. Today I am giving only about a quick sort technique because this is somewhat important sorting technique when compared to the other sorting techniques. So I am been explaining only with this technique. So quicksort technique, as the name indicates, a quick because it is the quickest sorting technique among all the sorting techniques available, and it is widely used sorting algorithm in large scale applications. For the small scale applications, we will be implementing the bubble sort algorithm. For with the large scale applications, the quicksort application is the widely used sorting algorithm which uses which are used to sort the data. Now why we are representing a quicksort algorithm is, if you are having n items in an array to sort, then how many passes it takes. So how many comparisons it takes or how many passes it takes means, with the earlier with the sorting techniques we are having n comparisons or n minus 1 comparisons or n passes or n minus 1 passes, whereas with the quicksort technique what happens is n log n comparisons. See, this is what here been representing, n log n. So n log n comparisons. So that means when we apply log factor, the value will get so much reduced when comparing the other sorting techniques. This is why the quicksort is widely used sorting algorithm. How many comparisons we are taking, how many passes we have been using with quicksort technique is n log n comparisons. But it is not easy to implement the quicksort technique. It requires some additional task, and it requires a large amount of application environment. It is not an easy method to perform like bubble sort, insertion sort, or selection sort. What we need to do with the quicksort technique is, it is nothing but divide and conquer method. What we are been representing with the quicksort technique is, we will be implementing the divide and conquer method. You know what the divide and conquer method is? Divide and conquer method is, suppose we are having n elements, divide the n elements into parts. Suppose having 10 elements, what I am doing with the quicksort algorithm is, now I am dividing the 10 elements into two parts. 5 elements one part, 5 elements one part. Now take the first part, divide that 5 elements into two parts such that 3 elements 2 elements, divide the 3 elements into two parts such that 2 elements 1 elements. So now what happens is, there is when we goes on dividing the elements, 2 elements 1 element, that will get a sorted position. Then again, so we will be conquering, that is first we partitioned, that is divided or partitioned the elements and made it into, with the partition itself we are making into sorted. And then what we are doing after sorting, we go on combining all the elements. That is called divide and conquer technique. So divide and conquer technique. So what is the main theme of main implementation in quicksort algorithm is partitioning of an array into parts. So that is the main implementation. So what we are doing is, there are several steps involved in quicksort technique. How we have been what are the steps involved in the quicksort technique is, first we are taking the first index of an array. So in order to make partition of an array, so what we need to take, we may partition array into two parts. Suppose if I am having 10 elements, 0 to 4 are one set, 5 to 9 are the another set. So that what I need is, I need first location, I need some middle location, I need the end location, such that I am using variables as left, right, LOC, and then these are the three primary variables that are been using here. So select first index of an array to left. First index of an array is, that is left, the first index of an array, that is 0, considering it into left variable. Similarly LOC, that is what we call as a pivot element or sorting element, that is what we call as element where we will be performing comparisons, a pivot element. We consider it as a pivot element, means based on that element we will be performing comparisons. So now what is the element that we are taking is, we are taking the first element for comparison. So now left, LOC and right are the three variables using here. Left stores the first index, that is 0. LOC stores the element for comparison, that is it stores the first element, and then last index, right, is the variable which stores the last index. Suppose if I am having 5 elements, suppose if I am having 6 elements, 0 is left, and then LOC, the first element, LOC itself is the 0, and then right, that is the last, 5 is the right. Now see here, that is what I am been representing here. Left equals to 0, LOC equals to 0, right equals to n minus 1, where n is the our size or length of the array. After representing these, after creating the variables, now from the step 3 our quicksort representation starts. What we are doing here, quicksort representation, in a quicksort representation we are partitioning the array into two parts, such that what we are doing is, in one case we are comparing the elements from left to we are comparing the elements taking from right side, scanning the elements from right side. In the second phase what we are doing is, we are taking the elements from left side. Why we are taking two parts is, that is what divide and conquer technique. We are dividing the array into two parts. Suppose having 6 elements, 0 to 2, 3 to 5. So now with one set what I am doing is, I am comparing from 5 to 3. In the other set what I am doing is, I am comparing from 0 to 2. So that is what we have been doing here in step 3. So what we are doing is, start from right of the array. So from right location of the array, starting from right. Right means last index of the array. Starting from right of the array, scan the complete array from right to beginning. What we are doing is, we will scan the array from right to beginning. So while scanning, what we are doing is, while scanning each element from right to beginning, comparing each element of the array with the element pointed by LOC. LOC is our desired value, desired location, that is desired location or desired element in a location which is used for comparison. Now taking from right side, starting from right side of the array, that is right side of the array means starting from right location of the array. What we are doing, suppose having 6 elements, starting from 5, a of 5, compare a of 5 with a0. If a0 is greater than a of 5, then we need to interchange. If a0 is not greater than a of 5, then we are not going to interchange, and then we are scanning with the next elements. That is the process we are doing here. What we are doing here is, we are scanning, we are comparing the elements with our desired element starting from right. So scanning elements from right side. So see here, starting right from array, scan the complete array from right to beginning. We are scanning the completed array from array right to beginning, comparing each element of the array with the element pointed by the location. Now what we are doing after this, we are checking a of location is less than a of right. If it is less than a of right, if this is the case, what we are doing is, we are continuing the comparison. If a of 0 is less than a of 5, then it is sorted out, then both the elements are in sorted position, so no need to swap. So what we are doing, we will come to the next step. A4, suppose a0 less than a5, condition true, then take a4 element, compare with LOC. Like that we will be performing. If wherever the desired, wherever the left, wherever a of LOC, wherever, when now we check a of LOC less than a of right, wherever a of location is greater than right, then we need to swap. Okay. Are you understanding? Wherever a of location value is greater than a of right, then we need to swap. That is the process we are doing here. Then swap the two values and go to next step. So now what we are doing in the next, what is the next step is, So we are swapping the elements. When we are swapping the elements, when we are finding a of location is greater than a of right. So a of location means that is the beginning value is greater than right side value. If the beginning value is greater than right side value, so compulsory we need to swap. So that we are swapping those elements. We are swapping with the beginning value with the right side value. We are swapping those elements. After swapping, what we need to do, we need to change the location. So the location is set with the right side index. With which variable, with which index we are swapping, that index is set to the location. So similarly, this is the process we are doing from a right side. Now what is the other process remaining here is the remaining process, this process continues with the right elements starting from right side. Now what we need to do next, second step, that is divide and conquer. So we are comparing values, we are performing a comparison of values from right side. So after that, what we need to do is the next phase is the comparing values from the left side. So start from element pointed by left. So now we start from taking the values from left side and compare each element in its way. That is, we are comparing the each elements. So what we are comparing, we are taking a of location value is greater than a of left. Now location moves to the right. So what we need to check, a of location is greater than a of left. So a of location value should be greater than a of left value because the location moves to the right index. So right side should be the greater value. Right side, that is A0, that is the left of the array. A5, that is the right of the array. So right side should be the greater value. So now we are checking a of location greater than a of left. If this condition, if this is the case, we continue. So a of 0 is greater than a of 5, no change. Next, a of 1 greater than a of 5. Next, a of 2 greater than a of 5. Like this we will be representing. Now what we are doing is, that is what we have been representing here is, if the right side value is greater than left side, we are scanning from left side and comparing with right side value. If the right side value greater than the left side values, A0 not A0, that is A5 value greater than A0, A5 value greater than A1, A5 value greater than A2. Like this we will be representing A4 value greater than A0, A4 value greater than A1. Like this we will be performing. That is, the right side values are greater than left side values. A of location greater than A of left. Then there is no change. When we are performing a change, whenever we are getting A of location, that is the right side value is less than right side value, A of location is less than A of right, then we need to swap the elements. So A of location value less than A of right, then we need to swap the elements, two values. Then the swap the A of location and A of right, such that we will be swapping the values. Sorry, here it is A of left. Now we are doing with left side. So A of location is already pointed to right. So A of location is less than A of location, that is the right side value is less than left side value. Then we need to swap the two variables. So what we are doing, we will be swapping the two variables. Then what we are doing is, again we move to step 3. What is step 3? Step 3 is, this is right. So now we need to again start the process, that is dividing. Now compare with the right element, again comparing with the left elements. That is what the process is. So now we move to step 3, that is we start again comparing with the right side elements. So after the process, what we are been representing is, whatever the partitions we are having, that partitions will get into a sorted, will get the elements in a sorted order. And then what we are doing is, we are combining all the partitions and making the array as a sorted array. So what is the best case we have been performing? Almost all the cases. What is the case that we are obtaining with the time taking for the quicksort is order of n log n. The time taking for quicksort is order of n log n. for better understanding, let us take a small example for better understanding of this. Now what is a quicksort algorithm is? Quicksort algorithm is, so now with this you can understand clearly what the quicksort algorithm is. Quicksort algorithm is to sort the values in an array by making the array into partitions such that so now I am starting the quicksort algorithm. Suppose I am having 6 elements. So taking 6 elements. So beginning of the array is less than end of the array. 0 less than 5. Beginning location of the array is 0. End location of array is 5. So 0 less than 5 condition true. So true. So what I am doing is I am partitioning the array. So now I need to partition. How I have to partition? I have to divide the array into parts. That is what divide and conquer technique is, the quicksort algorithm. Now what the process we need to do is we need to divide the 6 elements into parts. For that we will be calling the partition algorithm. This partition algorithm, what this partition algorithm does is it takes our given array, beginning location, end location, and then it needs a value LOC. LOC is the location which represents the two parts of an array. Beginning to LOC, one part, end to LOC, second part. Are you clear? What we are doing with partition? With the partition, how many elements we are having in an array, that elements will divided into parts. So how many parts? Usually you may assume into 2 parts. It will be divided into 2 parts. Now from where to where, that is the question. So now where to where means we always start with 0. 0 to 1 location. 0 నుంచి ఒక లొకేషన్ వరకు ఒక పార్ట్, అక్కడ నుంచి మళ్ళీ ఎండ్ వరకు ఒక పార్ట్. ఇప్పుడు ఆ లొకేషన్ వాట్ ఈస్ ఫ్రమ్ 0 to where up to where the first location is, that is identified by the LOC variable. Now when we call the quicksort process, what happens is first whatever the array we are having, onto that array the partition algorithm implements. The array is divided into 2 parts. So see, I will explain the partition algorithm. This is the example of array with 6 elements, an array with 6 elements. So now what we are doing, as earlier we said 0 less than 5 condition true. Now we need to partition. When we implement partition algorithm, we are getting a location. With that location we will be implementing the quicksort. See quicksort. So this is after the end of this partition algorithm, quicksort. After the end of the partition algorithm, see after the end of the partition algorithm, quicksort, array, beginning, location -1, that is one part. Again quicksort, array, location +1 to end index, that is the second set of the array. So with the partition process we get the two with this partition process the array is divided into 2 sets. Now coming to the partition algorithm, this is the partition algorithm. So beginning less than end. So how we are making the partition? The partition process itself contains the sorting technique. So what the partition process is, first we have to scan the elements. Step 1. So take left, location equals to left equals to beginning. First what is the process? First index array left and LOC to 0 position. Right equals to end position. That is what we have been taking here. So left LOC beginning position, that is 0. Right equals to end position, that is 5. Flag is the variable to perform loop. Flag is the variable used to perform loop activity. To repeat the loop for number of times we are taking a variable flag. So now while flag not equals to 1, flag is 0, 0 not equals to 1 condition true. When this true, what happens now? What we are doing, we have to scan, we have to start right from right of the array, scan the complete array from right to beginning. What we are saying this, first we are scanning the array from right to beginning. So that is what I am doing here. A of location, So first value, a of location value 90, location is 0, a of location value 90, a of location value 90. So 90 less than or equals to a of right, a of right value 67. So this condition is false. 90 less than 67 is, so 90 less than 67 is false. So this loop does not execute. False and anything will become the false. Now this condition. So while loop, this is the only statement in while loop. Right, minus minus is the only statement under this while. This is a separate statement. If lock equals to right, LOC variable equals to right. That is LOC means not lock, location. So location, what is location? 0. What is right? 5. So both are false. 0 equals to 5 condition false. Then coming to this statement, if a of location value, that is a of 0 value, that is 90. Now see here, 90 greater than a of right value 67. A of right is 5, that is 67. This condition becomes true. 90 greater than 67 condition becomes true. That is what we explained in step 3 and step 4. Now check a of location is less than a of right. If this is the case, we will continue scanning from right side. Now after this, suppose if a of location value, that is step 4.2 is there, if a of location value greater than a of right, if a of location value greater than a of right, then we are interchanging, and then what is the next step? We are making location equals to right. Now location becomes 5. What is location value now? Location value becomes 5, and then this process ends. The location value becomes 5, and then the process ends. End. If condition, this if condition becomes ending. So what we are doing here, location, we are changing this value here. It comes 90. Here it comes 67. And then the location equals to 5. Now what we need to do after to that, we need to check these moving to these this condition is finished. Now we have to scan from the left side. So if flag not equals to 1, flag 0, so flag does not change it, the flag value does not change it anywhere. Now we need to compare a of location value with a of left value. See next process. Now comparing with the left side, a of location. Now what is location? Location value is 5, greater than or equals to a of left. A of left value is 0. Left does not changes, location changes, left does not changes. A of location. Now what is a of location? A of location becomes 90 here. A of 5 location 90. 90 greater than or equals to 0, that is 67. 90 greater than or equals to 67, condition true. Location not equals to left, 5 not equals to 0, this condition true. So now what happens? Left plus plus. Now we comes to this position 1. Left becomes 1. Only this statement will execute in while loop. Left comes 1. Now same process, a of location. Location does not changes. A of location 90 greater than, what is a of left now? A of left is 23. 90 greater than 23, and location 5 not equals to 1, condition true. Same, left 2 plus plus. So now what is 2? Left plus plus 2. What is 2? A of left 101. Same, a of location 90 greater than or equals to, now it becomes 101. So 90 greater than or equals to 101 condition false. So now we come to this statement. If location equals to left, what is location? 5. What is left? 2. Condition false. Now else, if a of location, what is a of location? 5 less than a of left. What is a of left here? 101. So a of location value 5. A of location is index 5. Now a of location value is 90, and a of left is 2. A of left value 101. 90 less than 101 condition true, so interchange. So now here it comes 101 and it comes 90, interchanged. So after to that, what we are doing? We are making location to left. Now where the location value is, now the location becomes 2. So again we need to repeat the process from the right comparison. This process again, this loop comes while a of location. What is now location? 2. A of 2 is 90. 90 less than or equals to what is right value? Right value does not changes. Right value is 5. Wherever the right value does not changes. So far right value has not changed. A of location value is 2. That is A of location is 90. Less than or equals to A of right value. Right is 5. A of right 101. Condition true. And location. What is location? Location value is 2. 2 not equals to right value 5. Condition true. Right minus minus. Now we take this fourth index. Now we check A of location value. A of 90 less than or equals to 65. This comes 65, not 101, 65. Condition false. Here condition false. Now we check A of location value. What is A of location is 2. A of location value is 90 greater than A of right value 4. So that is A of 4 is 65. 90 greater than 65. Condition true. Interchange. So now this gets interchanged. Here we get 65. Here we are getting 90. So now after that location equals to right. Now location becomes 4. Again the process with the left side. So this process completes. So here what we are doing here, if you identify carefully, what we are doing when we are taking with the right part, the right elements will getting into sorted. See, first 101 comes into sorted position. When after that coming to the left part, so one element will coming into its sorted position. So within quicksort algorithm, what we are doing with the partition process, we are with the partition process, while the partition itself we are making the elements into sorted position. So with one while loop, with this right while loop, the right side